Hello and welcome to our first lesson in our course on basic systematic material selection. In this lesson, we're going to be focusing on the design process. But why? Why start here? I know that some of you are already familiar with the design process. We know it's iterative and that it can be described in many different ways. This is also where you perform material selection. It's because of this varying nomenclature and the importance of material selection that we're going to spend today's lesson in a bit of a review. As we stated in our introduction, we're going to be using Mike Ashby's textbook, Material Selection in Mechanical Design. So let's spend some time reviewing and getting everyone on the same page with the design process found in Chapter 1. We can see the design process from Chapter 1 here. But wait a minute, you might say. This looks linear. I thought you said the design process was iterative. And what is this concept, embodiment, and design stages? Let's break it down. We start with our market need. This is solving some problem that an engineer or designer has spotted. Now, this could be an original design, solving a unique and novel problem. Maybe new materials or new technologies allow us to solve something we never could before. Or we're simply solving something that no one else has. We could also be making an adaptive design, also called developmental design. This is where we're taking some type of product or product type and improving it. Well, why? Well, there are many reasons. We could be trying to make it more cost-effective for the final customer so that more people can get what they need. Or maybe we know there's a new material technology that means that we can make something better than what's currently on the market. Our final type of market need is a variant design. This is where we adjust the size or dimensions of a product without changing its ultimate function. Think of a single propeller plane compared with a military fighter jet. Both of them are airplanes, but they are very different. Now that we've identified this market need, we can move on to what we're going to call here the problem statement. Now, this is a critical part of our design process. This is where we're going to get a lot of our design requirements from. So it makes sense to spend a bit of time here during the design process. After all, things we decide here are definitely going to end up in our final product. Of course, as we're iterating through this and we learn something new, we should go back and adjust the problem statement as needed. We're going to be referring to this a lot during this course. Now we are entering the more iterative portion of the design process. This is where we will be focused a lot throughout our course. First, we have our concept phase. Here, we're brainstorming different designs, considering possible solutions for the function and structure of our product. Say we're designing a new vehicle to transport people around a busy city. We might be brainstorming the size, the type of fuel, is it autonomous, etc. Next, we're at the embodiment phase, where we'll be modeling and analyzing our various options and evaluating and selecting layouts. Here is where we may use CAD software or even 3D printing to make sketches and models of our designs, such as the car I'm showing here. Then we have the detail phase. Here is where we're analyzing the component in detail, optimizing performance and cost, and making our final choices of materials and processes. In our vehicle example, we'd be making final choices in material for various aspects of the car, identifying dimensions, and other details. We're going to come up with multiple concepts, embodiments, and even details as we're going through this process, constantly iterating and learning until we find the correct path through to our final product specification. Okay, going through this has added some clarity, but how do we get from our problem statement up here to our product specifications down here? Well, we're going to need a lot of different tools and data to help us work through the many iterations of our design process. The design of our part is ultimately the consideration of two equally important components: optimizing the part's size and geometry, and choosing the best material for the job. Now, here at Ansys, we have many different software tools to help in various aspects of the design process. In this course, we're going to be focused on Granta EduPack and Granta Selector, which can help select materials for design. And with that, we've come to the end of this lesson. we've reviewed the design process as explained in Mike Ashby's textbook. Stick around for our next lesson, where we'll be going into details about the Ashby selection methodology, a systematic way of taking our design problem statement and using it to identify key material constraints and objectives for material selection. My name's Dr. Caitlin Tyler. Thanks so much for joining me, and I'll see you in the next one.